Hello guys, welcome back, and we are continuing our series on data structures, and today we are going over sets. This is a pretty straightforward and simple data structure, and if you guys understand list and map, which I went over in last video, then this should be pretty simple. So what is a set data structure? Well, in simplest terms, set contains a collection of unique, unsorted elements or objects. If you remember in school, we learned about unions and intersections in our math classes, which is part of a set theory. This idea of set theory from math has been translated to programming languages as a form of set data structure. Now, in Java, we have three types of set: HashSet, LinkedHashSet, and TreeSet. Just like map, we have three very similar types of map, which again I went over in last video. So do check that video out if you guys aren't too familiar with the map data structure. So let's do an example of a HashSet. Actually, before we do an example of a HashSet, let's just quickly do an example of a list so we can compare the difference between them. So let's say we have a list that is of type string, and let's say we only have 3 elements in there. So let me import this list, and let's call this color list. So let's add 3 colors to it. And let's just quickly print this out as well. So we got our 3 elements in the list printed out, and let's try to create a hash set now, and it's pretty straightforward. We have this hash set class, and same thing, it's going to be of type string. And let's call this color set. And let's create this new object. And let's do the same thing we did with the color list with the hash set. All right, so we got our 3 colors printed out from our set and the 3 from the list above. So you guys are wondering, what's the difference between list and set? Well, we can see one difference right off the bat, and that is list is a collection of ordered elements, and set is a collection of unordered elements. You can see that our list maintained the ordered, so we added blue, red, and yellow. It was able to print that out in that same order. While in our set, it did not maintain that order. You can see we got red, blue, and yellow. So that is one of the difference between list and set. The other biggest difference is that list can contain duplicate elements, and set can't. So if I were to add, let's say, another red to our list, and let's do the same thing for our set, let's add another red. Our list can contain duplicate elements, so we're going to see red printed out twice. And in our set, we're only going to see red printed out once. So you can see in our list, we see red twice, and in our set, we only see it once. So set contains only unique elements. Another difference I want to mention is list is index-based. So we can easily search by index and retrieve that element by index. So we have this get method that's part of our list where we can retrieve an element at a specific index. Now, if you go to our set, set is not index-based, so we cannot easily search or retrieve an element at a specific index. And we can see we don't have this get method available in our set. So if you want to get an element by index, we will need to convert that set to a list. And that is pretty simple to do. We have this to in our stream. We have that to list available to us that's going to convert this to a list. And we can just save this to a new list. So let's create a new list of type string. And let's say color convert list. And let me actually place this at the bottom here. All right, so let me print this out. All right, there you go. So we got our list here. And so we have now access to those same methods as well. So we can get an element by specific index. So let's say I want to get the first element. I'm just going to do 0, and let's print this out. And let me remove this, and let's run this. So here we can see our first element, or at index 0, is red. Now, one thing I want to note is this convert list, this color convert list, is immutable. And what that means is we cannot make any changes to it. So for example, if I want to add a new color to it, let's say maybe, I don't know, purple, we're going to get an error. So if I run this, I'm going to get an error. It's saying immutable collection. So basically what this means is I cannot make any changes to this list. Now, if you want to create a new list where I can make changes to it, the way I would do that is, let me comment this out. I'm going to create a new list. And let me just call this the same list. And it's going to be new type of array list, and here I can pass in inside this parentheses the name of our set. So now I can add this new color, purple. So if I run this, actually let me print this out as well. There you go. So you can see we got our purple as well in this new list. Okay, so let me remove this and let's quickly discuss union and intersections. Let's have another color set that has 3 colors, green, blue, and purple. So let me just copy this and add those 3 colors. So let's do a union and intersection of these 2 color sets. And basically what union is where we take all the unique elements from both set and merge them together into one single set. And intersection is where we take the same elements from both lists. So in this case, set. And in this case, we have blue. That's part of both sets. So let's try to do that. So let's do a union first, and it's pretty simple. We just take our first set, and we have this add all method, and we just add the second set. So just color set 2. So let's print this out. All right, let's run this. So you can see we got all the unique colors from both of the set, red, green, blue, yellow, and purple. Now let's try to do intersection, and it's pretty simple, same thing, except we have this method called retain all. So we just replace add all to retain all. And let me comment this out, and let's run this. It's not union, this is called intersection. So let me just rename this. So you can see the intersection below returned as one color, blue. Why? Because blue was part of both set from color set 2 and color set 1, the first one. All right, let's quickly discuss how HashSet work internally. So internally, HashSet uses HashMap, and this ensures there will never be a duplicate element inside a set. So if you go to this add method, and if you take a look at inside how this works, you can see it's using a map. So if we take a look at this object, you can see this is a hash map. And over here, you can see it's checking like if an element is present. If it's present, it's gonna return false. So let's debug and let's see how this is working. So let's set a breakpoint here, and let's run this in debug mode. So if I go inside this map, let me set a breakpoint there. And if we evaluate this, you can see inside our map we have red there already. So now this new red is going to return as false. You can see it's false. Why? Because the red is already inside this hash map. And if I go there, it doesn't insert that inside our set. So this is how HashSet works internally. All right, now let's quickly go over the last 2 types of set, LinkedHashSet and TreeSet. I went over this in the last video as well for hash maps, and it works exactly the same way for set. So let's do LinkedHashSet. And let's do the same example we did here for color set. So let me copy this. And let me just leave that there. And let me comment this out. So let's replace this with LinkedHashSet. I'll just call this color L set. And this would be LinkedHashSet. All right, let's run this. Okay, so this is our regular hash set, and this is a LinkedHashSet. So let's review this. So if you go to our regular hash set, you can see we first inserted blue, red, and yellow. You can see it did not maintain that order. So HashSet doesn't maintain any ordering of the elements the way they were inserted, while the LinkedHashSet maintained the order. So you can see first we inserted blue, we got blue there, then we did red, we got red, and the third element was yellow, and we got yellow here. Now let's go over the final type of set, which is TreeSet. And TreeSet actually sorts based on the natural ordering of elements by using the compare to method. And this tells us how to sort the elements, whether in ascending or descending order. Let's do the same example using TreeSet. So I'm going to copy this and pretty much just replace this with TreeSet. All right, let's run this. So let's take a look at the output. All right, so at the bottom we have TreeSet, and this sorts the color in ascending order. And above we have LinkedHashSet, which doesn't do any sorting, and it only maintains the ordering of elements in the way they were inserted. And above, we have the HashSet, which doesn't do any sorting nor doesn't maintain the ordering of the elements. And in TreeSet, we can even sort this in descending order. So we have this descending set. So you can just call on that. And now it's going to sort this in a descending order. So we got yellow, red, and blue. And we also have some other nice features that comes with TreeSet. And let's say we want to return a set of element that is greater than some value. So let's say, give me all the string colors that is greater than red. So we have this tail set, and over here we can say red. So it's going to return us all the string colors that is greater than red. So we should get, and by the way, this is inclusive. So we should get red and yellow output. So if I run this, we're going to get red and yellow. And the opposite of this is head set. So basically return me all the elements that is lower than red. So in this case, I'm only going to get blue. To recap, we went over what a set data structure is. It's a collection of unique elements or objects, meaning it doesn't contain any duplicates. We then discussed the difference between list and set, and there are three major differences. First is that list maintains the order of elements in the way they are inserted, and set doesn't. If you want to maintain the order of elements inside the set, we have to use LinkedHashSet. The second difference is list can contain duplicate elements, and set can't. And the third difference is list is index-based, meaning we can retrieve an element by index, and in set, we can't do that. If you want to do that, we would need to convert that set into a list. We then briefly discussed how HashMap works internally, and it basically uses a hash map to ensure no duplicates elements are inserted. At the end, we went over two other types of set, LinkedHashSet and TreeSet. LinkedHashSet maintains the order of elements in the way they are inserted, and TreeSet sorts the element based on the natural ordering of the elements. And HashSet doesn't maintain any order, nor does it sort the elements. Hopefully this video helped you understand how sets work and when to use them. And I will see you all in the next video, which will be on stacks. Take care.